Okay, so the first question is, when the following are evaluated, how many of the answers are odd? So the numbers are 1 squared, 2 cubed, 3 to the power of 4, 4 to the power of 5, and 5 to the power of 6. So we know that 1 squared is equal to 1, so clearly that's odd. 2 cubed is equal to 8, which is even. And then 3 to the power of 4 is 81, which is odd. 4 to the power of 5, well, 4 to the power of 5 is just 4 times 4 times 4 times 4 times 4. And so if we multiply even numbers, we're going to end up with an even number. And so 4 to the power of 5 is even. And then 5 to the power of 6, well, 5 times 5 is 25. And so if we keep on timesing a number that ends in 5 by 5, we're going to carry on getting numbers that end in a 5. And since a number that ends in a 5 is odd, 5 to the power of 6 must be odd. And so we have 3 odd numbers, and so the answer is C. Okay, so the second question is, the positive integer 2018 is the product of 2 primes. What is the sum of these 2 primes? So clearly 2018 is a multiple of 2, and so we can write 2018 as such. 1009. Okay, so clearly 2 is a prime, and 1009 must be a prime also, because if it wasn't a prime, we could then split it down further, and then 2018 would be the product of more than 2 primes. And so this means that 1009 is the other prime, and so this sum is 1011, which is C. Okay, so the third question is, which of the following shows the digit 6 after it has been rotated clockwise through 135 degrees? So if we think about what the digit 6 looks like after it has been rotated by 90 degrees, it will look something like this. And then if we think about what it would look like if we rotated it through 180 degrees, it would look like a 9. So it would look something like this. And so 135 degrees will look something halfway between a 90 degree rotation and a 180 degree rotation. And if we quickly scan through all the options, we see that the answer must be D. Okay, so question 4 asks, which of the following is not a multiple of 5? So I think the best way to answer this question would be to just go through each of them in turn. So let's start with A. So A is just a difference of 2 squares, and so we can rewrite it as 2019 plus 2014 multiplied by 2019 minus 2014. And clearly this is a multiple of 5 because the second bracket 2019 minus 2014 is equal to 5. Now let's look at B. Well, B is equal to 2019 squared times 10 squared. Clearly this will be a multiple of 5 because we are timesing 2019 squared by 100, and 100 is a multiple of 5. So B is a multiple of 5. Now let's look at C. So C. Well, so we want to work out 2020 squared divided by 101 squared. Well, 2020 squared can be rewritten as 2002 times 10 squared, which is the same as 202 squared times 10 squared divided by 101 squared. Now clearly 202 squared divided by 101 squared will just be 4, because 202 divided by 101 is 2, and so if we square that we get 4. So C is equal to 4 times 10 squared, and by the same argument as we used in B, if we're timesing a number by 100, it must be a multiple of 5. So clearly C is also a multiple of 5. Now let's look at D. Well, D is similar to A in the sense that we can use the difference of two squares, and so D will be equal to 2010 plus 2005 multiplied by 2010 minus 2005. And since the second bracket is equal to 5 again, D must be a multiple of 5 also. And so by the process of elimination, we know that the answer must be E. Okay, so question 5 is, which of the following numbers is the largest? So if we quickly look through the options, we can clearly see that trying to manually work out each fraction and then compare their magnitude will take a lot of time and effort. And so the best way to do this is to, if you quickly look at the fractions, you can see that B, which is 487 over 121, is greater than 4 because 121 times 4 is 484. So we know that B is greater than 4. And so now let's look at A. So A is 397 over 101. But 101 times 4 is 404. And so clearly A is less than 4. And so since B is greater than 4, A cannot be the largest. So we can rule out A. C is 596 over 153. And if we just take 150, well, 150 times 4 is 600. So clearly 153 times 4 will be greater than 600. And so clearly C is also less than 4. And if we now look at E, well, 200 times 4 is 800, which is greater than 796. And so clearly 203 times 4 will also be greater than 796. And so E is less than 4 as well. And so if we now look at 678 over 173, well, we can just quickly work out 173 times 4. And if we do, we get, 4 times 28, 9, 2, we get 692. So 173 times 4 is 692. And so clearly D is also less than 4. This means that the correct answer is B. Okay, so question 6 is, which of the following is equal to 25 times 15 times 9 times 5.4 times 3.24? So if we quickly look at the answers, we can see that all of them are in terms of powers of 3. And so this suggests that the best way to go about answering this question would be to write the product in the question in their prime factorization form. And so 25 is equal to 5 squared, and so the product is 5 squared, times 15, which is 5 times 3, so 5 times 3, times 9, which is 3 squared, times 5.4, which is 54, divided by 10, times 3.24, which is 324, divided by 100. And so if we rewrite these fractions in terms of their prime factorizations, well, we get that 54 divided by 10, well, 54 is equal to 27 times 2, which is 2 cubed times, 3 cubed times 2, and 10 is equal to 2 times 5. So this fraction is the same as 3 cubed times 2 divided by 2 times 5. And then 324 divided by 100, while 324 is the same as 18 squared, and 18 squared is 3 squared times 2, and so 18 squared would be 3 to the power of 4 times 2 squared, divided by 100, which is 25 times 4, and so is 5 squared times 2 squared. So if we now tidy all this up, we get that the product is equal to 5 squared times 5 times 3 squared times 3 cubed times 2 over 2 times 5 times 3 to the power of 4 times 2 squared divided by 5 squared times 2 squared. Okay, so we can now start cancelling some terms. So clearly this 2 will cancel with this 2. This 2 squared will cancel with this 2. We have a 5 squared here, and we are dividing by 5 squared here. And so these will cancel each other out. We're timesing by 5 here and divided by 5 here. And so these two will cancel out. And so what we end up with is 3 times 3 squared times 3 cubed times 3 to the power of 4, which if we add up all the powers is equal to 3 to the power of 1 plus 2 plus 3 plus 4, which is the same as 3 to the power of 10. And so if we look at our answers, clearly the answer is B. Okay, so the 7th question is, the circles P, Q and R are all tangent to each other. The centres all lie on the diameter of P as shown in the figure. What is the value of the circumference of Q plus the circumference of R divided by the circumference of P? So if we let the diameter, so I'll just write a small d as diameter, so d of Q, let's let that be equal to small q, and the diameter of R to be equal to R, well then the circumference of Q, so I'll just write circumference as small c, so C of Q will be equal to the pi times the diameter, so pi Q, and the circumference of R will be pi R. And so the sum of the circumferences will be pi Q plus pi R. And so now let's work out the circumference of P. Well, the diameter of P will just be the diameter of Q plus the diameter of R. So d of P is equal to Q plus R, and so its circumference is equal to pi Q plus R. And so the fraction will be pi Q plus pi R divided by pi Q plus R. And if we expand this fraction, we'll get pi Q plus pi R. And so clearly the top of the fraction is the same as the bottom of the fraction. And so this must be equal to 1. And so the answer is A. Okay, so question 8 is, what are the last two digits of 7 to the power of 218? So if we quickly look at the answers, we can see that all we have to do is to consider the last digit of 7 to the power of 218, because each of the options has a different last digit. Okay, so now let's think about what the last digit could be. So if we have 7 to the power of 1, this will equal 7. And 7 squared will equal 49. 7 to the power of 3, well, if 7 squared ends in a 9, then clearly 7 cubed must end in a 3, because 9 times 7 is 63. So that ends in a 3. 7 to the power of 4 is equal to, well, clearly it must end in a 1, because 3 times 7 is 21. So this must end in a 1. And then 7 to the power of 5, well, that must end in a 7, because 1 times 7 is equal to 7. And if we then worked out 7 to the power of 6, we would get that it must end in a 9. And so as you can see, we are now just repeating the last digit, because we started off with a 7, then we went to a 9, a 3, then a 1, and then we looped back around to the 7. And so clearly there are only 4 possible values for the last digit of 7 to the power of something. And if we work out the remainder when 2018 is divided by 4, then we can work out which of these is its last digit. If we take 7 to the power of 7, for example, well, 7 divided by 4 is 1 remainder 3. And so clearly it must end in a 3 because of the pattern that we have just found in the last digit. And so 2018 divided by 4, well, clearly 2016 is divisible by 4, because any number ending in a multiple of 4 is a multiple of 4 itself. And so 2018 divided by 4 has remainder 2. And so this means that 7 to the power of 2018 must end in a 9, because 7 squared is 49. And so therefore the answer is B. Okay, so question 9 is, the diagram shows a rectangle AEFJ inside a regular decagon ABCDEFGHIJ. What is the ratio of the area of the rectangle to the area of the decagon? So one way to tackle this question would be to call the length of one of the sides of the decagon L, and then work out the area of the decagon and the area of the rectangle in terms of L, and then find out their ratio that way. However, that would be a very difficult method, because finding the area of a decagon in terms of its side length is very difficult. So we need to think of a different method to solve this question. And the method that I would use is as follows. So what we can do is we can mark the center of the decagon, which would be about here. And let's call that point O. And what we can then do is we can join each vertex of the decagon to the point O as such. And if we carry on doing the whole of the decagon, then we will split the decagon into 10 equal triangles. And so let me just write this down. So decagon equals 10t, and the t just means 10 triangles. Now let's consider the rectangle. So I'm just going to quickly rub out all these lines, and I'm going to mark the center again. Okay, so now what we can do is we can clearly see that if we join the point O to each of the vertices of the rectangle, so to A, to J, to F, and to E, we can clearly see that we have split the triangle, that two of the triangles, namely AOJ and EOF, are the same as two of the triangles of the decagon. Now, however, let's consider the triangles AEF and FOJ. Well, clearly the triangle FOJ has the same base as the rectangle, but only half the height of the rectangle. And so FOJ and EOA are each a quarter of the area of the rectangle. And if we then consider the triangles EOF and AOJ, while the triangle EOF has a base equal to the length of the rectangle, and also its height is equal to half of the rectangle. And so the area of EOF is also a quarter of the area of the rectangle. And the same goes for the triangle AOJ. And so this means that the triangles EOF and AOJ both have the same areas as the triangles EOA and FOJ. And this means that the rectangle is made up of 4 of those triangles that the decagon was made out of. So rectangle is equal to 4t. And so this means that the ratio between the area of the rectangle and the area of the decagon is 4t to 10t, where t is just the number of those triangles that we talked about in the beginning of this question. And so clearly the ratio, if we simplify it, will be 2 to 5, which corresponds to answer A. Okay, so question 10 is, on a train ride, Laura averages speeds of 12 kilometers an hour for 5 minutes, then 15 kilometers an hour for 10 minutes, and finally 18 kilometers an hour for 15 minutes. What was her average speed for the whole ride? So the way we're going to work this out is we're going to work out the total distance she traveled for each of the 3 parts of her journey, and then we're going to divide that by the total amount of time for each journey, for each part, to then find out her average speed for the whole journey. So let's consider the 12 kilometers an hour for 5 minutes. So 5 minutes is just equal to 5 over 60 hours, which is equal to 1 over 12 hours. And since distance is equal to speed times time, she traveled 12 times 1 over 12, which equals 1 kilometer in that part. In the second part, 10 minutes will be equal to 10 over 60 hours, which is 1/6 of an hour. And so in the second part, she traveled 15 times 1 over 6, which is equal to 15 over 6, which can be simplified to 5 over 2 kilometers. Now for the third part, 15 minutes is equal to 1/4 of an hour, and so her distance in the third part will be 18 times 1/4, which is 18 over 4 kilometers, which equals 9 over 2 kilometers. And so for the whole journey, the total distance you traveled is 1 plus 5 over 2 plus 9 over 2, which is equal to 1 plus 14 over 2, which is equal to 8 kilometers. The total time she took to travel 8 kilometers is 5 plus 10 plus 15, which gives you 30 minutes. So if 8 kilometers took her 30 minutes, then clearly 1 hour, which is 60 minutes, would take her 16 kilometers. And so she must travel 16 kilometers an hour, and this corresponds to D.